Hey everybody, we're going to take some notes on triangle congruency. I'm focusing on angle side angle and angle angle side. So they're just two of the other types of ways triangles can be congruent. So just like always, we need to fill in the notes. So if we're doing angle side angle, that's where there's a side that is congruent in between two congruent angles. And in this picture, we have angle A is congruent to angle D. Side AB is congruent to side DE. And angle B is congruent to angle E. Then therefore, when we read it, we have angle, side, angle. You always read one triangle and you read it in a counterclockwise or clockwise rotation. So if you read it this way, it's the same thing. Angle, side, angle, angle, side, angle. Okay? It kind of copied a little sideways. So just like we did the proofs in side, 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 and side, angle, side, when you read your given statement, you are going to identify what you know, and you're kind of going to talk through it. So SQ bisects angle Q, RQT, and RST. That is given. And, okay, so SQ bisects angle RQT. So that means RQS and TQS, which is this statement right here, are now equal because of an angle bisector. Then if we read the second half of this, SQ bisects angle RST, here's RST, and this angle has been cut. So now RSQ and TSQ are now equal. That again is angle bisector. Okay. QS is congruent to QS, that's reflexive. And angle, side, angle. You always read one triangle. So if we do this top triangle, we have this little angle, this side, and that little angle. Angle, side, angle. Okay. You're told that JK is parallel to LM. That was given. And JL is congruent to KM. So when you have two different parallel lines, you do the two arrows. Okay. So now that we have two parallel lines, whenever you have a parallel line, you're always going to identify a type of angle. So JKL and MLK are alternate interior angles, and JLK and MKL are also alternate interior angles. KL is congruent to KL, that's a reflexive. And then we have angle, side, angle. We always throw in there that you have to do the reasons and statements for both, so here we go. Angle BAC is congruent to angle DEC, so identify that. BAC, DEC, that was given. And C is the midpoint of AE. So if C is the midpoint of AE, that means, that means AC is congruent to CE by the definition of midpoint. Then we need to identify something else. We've kind of ran out of options, right? But you have two intersecting lines. So these angles here are vertical angles. So BCA is congruent to angle DCE, vertical angles. Then triangle ABC is congruent to triangle EDC by angle, side, angle. Okay. angle, angle, side. So this is where the side is not in between the two angles that are congruent. So angle A is congruent to angle D, angle B is congruent to angle E, and BC is congruent to EF. Then we have angle, angle, side. When you read this angle, angle, side, say if you read it backwards, side, angle, angle, it's just saying it backwards, side, angle, angle. So either way you read it, it is fine, but this is kind of the one where if you read it backwards, it doesn't specifically say AAS. It says SAA, okay? So here are the ones you gotta fill in. YZ bisects angle WYX. You don't need to do all of these in order, okay? There's like other ways that you could write your proof. So right here, if I'm told that YZ bisects angle WYX, I'm going to say WYZ is congruent to angle XYZ because angle bisector. Then we have angle YWZ is congruent to angle YXZ. So YWZ and YXZ, because that was given. Then YZ is congruent to YZ because it's the reflexive property. And triangle WYZ is congruent to triangle XYZ because angle, angle, side. Okay. Angle ABC is congruent to angle CED. So ABC, CED, that was given. AB is parallel to CE, that was given. So AB is parallel to CE. Oh, I'm sorry. So if you're here, you have two lines that have been cut by this transversal. So that means these two angles are now equal. So BAC is congruent to angle ECD because these are corresponding angles. Then our last given we have, C is midpoint of AD. So C is the midpoint, so that means AC is congruent to CD. And then, oh, I'm sorry. See, I just get so ahead of myself. So triangle ABC is congruent to CED by angle, angle, side. PR bisects angle QRS. So PR bisects QRS. So angle QRP is congruent to angle SRP because angle bisector. And we're told angle PSR is congruent to angle PQR. So PSR and PQR, that was given. And PR is congruent to PR, that's the reflexive. So triangle PSR is congruent to triangle PQR, and that is angle, angle, side. Last one. LG is parallel to JM. That was given. So if you ever have LG is parallel to another line, two lines that are parallel, you are going to identify, a type of angle. So we have LGJ and MJH. Those are alternate interior. So angle LGJ is congruent to angle LJG. Now, this one was tricky because you could have also identified these angles, but there's like multiple ways of proving triangles are congruent. So it's still going to lead you to the same conclusion, but I'll show you. H is midpoint of LM. That is given. So that means LH is congruent to HM by midpoint. Then it doesn't matter. So say if we do identify these, it would be angle, angle, side. That is fine. Or we could have identified this vertical angle here. Again, it's angle, angle, side. It doesn't matter. So angle GHL is congruent to angle MH. Oh, I'm sorry. Angle LHM. So like for here, angle G, you have to say angle L first. We've been doing that though. Vertical angles. So I'm just shorthand for right now. Triangle, triangle, angle, angle, side. And there we are. So I hope this helped.